Let's take a look at what went wrong for Agent 00 Dalton. Once our respected field agent's gun jams, Newton's first law works against his favor. Without the force of the firepin, the only forces acting on the bullet in the chamber are normal force from the barrel and the bullet's own weight. As the bullet has no momentum and no forces acting on it horizontally, it remains at rest, unable to reach the intended target. On the other hand, Newton's first law aids the Manila Bandit, otherwise referred to as Dean. Without an additional force that a bullet would apply, the bandit maintains constant velocity while fleeing the scene and stays at equilibrium. Let's see what would have happened if Sir Isaac Newton was on the side of justice.
Justice has been served.
The impact of Agent 00 Dalton's bullet causes an increase in the Manila Bandit's horizontal forces in addition to his applied force while running. This addition of force in one direction causes the combined force of two different applied forces to overcome the force of friction, making the Manila Bandit accelerate due to a lack of equilibrium. And like a good field agent, Agent 00 Dalton always cleans up after himself. Upon impact, the bag is only being affected by the force of gravity and the buoyancy from the water. Due to Newton's third law, which states that for every action there is an equal and opposite reaction, it can be deduced that the forces exerted on each object in this example at the moment of impact are equal. Because force is mass times acceleration, it can be found that the acceleration of the bag was exponentially higher than that of the water, but the collective mass of the water was so much larger than that of the bag that the forces cancel out and create an equilibrium in the oppositional forces of buoyancy and weight. Fundamental to every action and experience in the natural world, the role of oppositional forces described by Newton's third law of physics is irreplaceable, and without it, the world would not be the same. For example, if the bag in our last demonstration met no oppositional force, it would continue on its path until it reached the bottom of the pool, if not farther. The buoyancy of the water would be non-existent and unable to stop the bag from accelerating due to gravity, making the small body of water as fluid as the air the bag was thrown from.